morning, Malcolm.
Morning.
How are you, man?
Tired. Actually managed to sit down and do some of my overdue assignments for this class.
Nice.
Not as many as I'd hoped, but a few.
Yeah.
And then on the reverse game, I just couldn't get that one stupid loop to work. So instead of, the nice 6-line loop, I have a 351-line switch statement. Because I just couldn't get the loop to work, but damn if the code wasn't going to work right.
That's funny.
And I'm still frustrated about it, because, if you look at it, it's what, actually, I was talking to a different person about it. Where is it? Test equals the first slot of, array I, when I is equal to 0. Array I is equal to the swap value. Swap is equal to test. Move test forward 1. Same thing again.
Yep.
It's like, you look at it and it's such an easy, that's a loop. That should be a loop. That's very clearly meant to be a loop, but I couldn't get the loop to work.
You know what? Let me look. I had something similar to that, and it may have been in that one. This was the reverse game?
Yeah. Yeah, the file size went from 4 kilobytes to 16.
What did I do? No, I had one where I had an issue that my loop was resetting every time. It was turning into an infinite loop, and after Professor looked at it, he was like, "Oh yeah, there's your problem," and it was that the value that I was using for the loop, as it went through the loop, it kept resetting. But it wasn't this one; it was a different.
Yeah, at the bottom of my code, I have like 2 or 3. I have, because on the September 14th or whatever, he'd gone over like, here's a basic reverse loop that goes through the entire thing. Change that to do it. So I based my loop off that, and I tried to make it, and it didn't work. I either went infinitely, caused a core dump. Or just didn't work at all. No matter, and I couldn't get it to work, and I don't understand why. Looking at it,
have him load it up.
Good. Well, yeah. I mean,
he can load it up, and I don't know if you've seen him do that with some of the programs, but he'll load it up and look through it, and it's really cool to see.
And of course, there's the other one where when I first did the assignment, I watched the video.
Recording in progress.
And my understanding was that you were just meant to swap the first value and the value given. So I wrote that one, and that was super simple. And I was like, oh no, that's not it.
I don't need no approval. I'ma just do whatever I feel like. Going out all night with my friends, spend the whole day just laying in bed.
So now I have a 351-line, 19K switch statement.
That's funny. Yeah, I just finished the crack password.
Yeah, that night I sat there and I started on them, and I was like, I'll get like 4 of my things done tonight. I ended up getting 2 done because I just kept running into stupid mistakes.
I do the same thing. I tend to, I don't know the right word. I guess I think that I'm better at it than what I am. And so I sit down and I'm like, I can knock this out in 15 minutes. And let's see, I sat down at 8 and I just finished it. So it was about an hour and 15 minutes to do.
Why do you even bother making up problems? I don't got time for that, no.
Yeah, I did that one, and I did capitalized words, which I also was just being stupid.
Yeah.
Because at first I was testing, I was like, I totally know how the values on ASCII table work, and I didn't look. And I was testing to see if they were higher than the uncapitalized letters instead of lower.
Oh yeah. You know what though? So what you should do in that is if you put the letter inside of the char single quotes, it'll pull the ASCII value for you. So instead of
Well, I mean,
writing
if
the
you-
numbers, you can actually just do A or B or C lowercase. Right?
Well, yeah,
And then
I know
compare
that
it
one
to
because
the capital.
we did that on in a different class. I'm forgetting what class it was right now, and we were doing actually a lot of the. It might have been another class with Barry as a professor because a lot of these assignments are seeming very familiar,
Yeah.
like hashing and cracking passwords and the huge loops for that. But so I knew that part. I just was being stupid in the way that I was setting up the equalities, or rather than the one greater than less thans to make it work. And once I realized that, of course, it immediately, and remembering that space is an actual thing that isn't equal to null also helped.
Yes, it is.
Yeah, because having my, you had to set up like an if-else loop for the first one being to test if the 0 slot, so the first letter is capitalized, do not capitalize that, and then afterwards look for spaces and capitalize everything after it, or the letters after it. And for a long time, and kind of embarrassing long, I forgot that space was actually a thing that didn't equal null.
Nope, it definitely doesn't.
So all the stupid little mistakes. All of them.
Good
Good morning.
Hi.
How are you?
Good.
Good.
A little washed out again.
I have the window, so I bought a different desk, and the one that I had before is back here behind me, but it's got a recessed area for my monitor, and I use 3. I mean, my monitor area is big.
There you go.
So it would close in the 2, and when I put my head down to write, I could feel the heat from the monitor on my face, and I'm like, no, this isn't gonna work. So, and I wanted to stand. I don't like sitting for very long.
Yeah.
So I bought a desk that I can just move up and down. So,
Nice.
but yeah, the whole point of that story is that the window's right in front of me. So I have natural light coming in. Well, it's natural light with clouds, but So I bet if I
I'm
Less
curious,
washed out?
Barry.
Not much different.
Barry, how much did you see my message on Discord over the weekend?
Which one?
Well, the one just in the Discord about my issues setting up a loop.
Oh yeah, a giant. You couldn't figure out the loops. So you just did a whole bunch of if-elses.
Yeah, well, no, a switch statement with cases, because I mean that I've used that once before years ago for a different class, and I was like, oh, that'll work, and it worked.
Well, yeah, it does work.
It's just 351 lines. Because I couldn't get the loop. I'm still annoyed by it, because you look at it and it's such an easy. Oh, that's a loop. That should be a loop. It's such an. You can see.
Are all the cases similar to each other?
Well, yeah. Well, yes. It's even in the case. It's a single block that I had to copy and paste and then change the numerical values in. So it's super obvious it should be a loop, but I couldn't get it to loop.
What you need to do is you need to write a program to write that case statement for you. You just write a program and it just loops through and it just writes all those cases for you, and then you just paste it in.
Yes, I have that
actually,
on the reverse
done
game.
that is a valid. I had to write a program that had a huge number of if-else's in it, and they were all slightly different from each other.
Ah, jeez.
So yeah, I wrote a program to write that program.
Yeah, that one keeps bugging me.
Oh, let's see. So I just rolled out of bed actually.
Same.
45 minutes ago.
good for you.
I got 2 problems here. One is everyone in my house is sick except for me.
Oh no.
Or getting over something, right? So my 16-year-old has been out now for a week and a half with just it must be some kind of mild flu, but it's long lasting, right? So he's still got like congestion. So he's ready to go back to school, but the school would probably go home. You're sick, right?
Yeah. Yep.
And then my 8-year-old, he right after trick-or-treating with his friends, he goes, I have a sore throat.
Oh no, that sucks.
I'm like, yeah, so after the friends we told you were not sick. Now you're telling me I'm sick. So he's
That's
home
a
with
bummer.
a 103 fever, which is the same symptom my 16-year-old had. High fever at first, and then the sore throat thing starts.
Yeah.
And my wife's getting over probably the same thing. And so far, I haven't been affected. Although I can tell something's in my chest, so I'm coughing a little bit, but I'm not like having a fever and
Yeah.
all that. So
Well, that's good at
managing
least.
to stave off whatever it is or fight it off.
Yeah.
And so as a result of that, no one had to go to school, right? So I slept.
Yeah.
And plus, it's dark.
It still is a little dark, huh?
Yeah.
Well, hey, you know, good sleep's hard to come by, so if you can get it, you might as well take advantage of it.
Yeah. Let's see. People on YouTube. We got people listening from Canada and Serbia, among other places.
Well, okay then.
I may end up turning off the music at some point because yesterday's video got tagged for copyright violations. Because their content ID, YouTube's content ID, misidentified the song. They were so quiet, I think it misidentified them. And so when you go in and you register a dispute, and it says like, what's your reason for a dispute? And one of them is like, you know, I own the rights to this. One is I'm licensing the rights. One is, I own the copyrights to it, something like that. None of the options are you misidentified the track.
Well, of course, they can't do anything wrong.
Right. So I just said,
That's so
delete
funny.
it. I don't feel like fighting that battle. Let's turn off the music.
Yeah.
So how is the current assignment going?
I'm just freeing stuff up now. I did the assignment. It's all done. I had so much fun with that. Once I got it working, then I was like, I got into the million one, and I actually had my mom come in, and she picked one of the words on there so that I couldn't see it, and put it in there, and I was able to hash it, and yeah, it was super cool.
Yeah.
So it was really fun.
I overheard
Yeah, I had a
you
lot of fun
saying,
with it.
I think right before we started, that the program took a little bit longer than you anticipated.
No, I just overestimate my abilities.
Sure.
So I look at it and I'm like, 15 minutes, I'll have this done, no problem. And then I sit down and it ended up taking longer than that. And it's actually a silly reason, but I trimmed off the new line character on the passwords, but I didn't trim off the new line character on the hashes. So when it was trying to find it, I actually had it printing out, and I'm like, no, they're the same. Why is this not working? I'm like, there's something wrong with my compare code. And I was going through it and going through it. So I spent probably 45 minutes, excuse me, messing around with.
When I heard you
Messing
talk
around with
about overestimating your ability or underestimating the time, it just like reminded me of a blog post I had read probably 10 years ago by Steve Yagi, who used to work at Amazon. And he was a developer, and then he worked his way up to finally being like project managers, and then he went on to form his own company. And hold on a sec. And developed his own like bug tracking and issue tracking software. And one of the things he wanted to do was, when you are a project manager and you assign your developers to work on little projects, like fix this bug or implement this feature, you want to get an estimate about how long you think it's going to take, so that you can allocate your resources effectively. So, if you've got like 100 things you need to get done, you want to ask your developers, how long do you think it's going to take you to do this one thing, so that we know how many you can do in, let's say, 2 or 3 weeks. And the problem is a lot of developers underestimate how long they think it's going to take, or they overestimate their abilities. So they make like, oh, look at this. I think it's going to take an hour to do it, but it actually takes 4.
Yeah.
And he said, estimating your time is a good skill to have, but we could write some software that could help with that. And he said, the software is not being judgmental. When you get assigned a job to do, you put in your estimate as to how long you think it's going to take. So right off the bat, before we've done anything, he says, take a few minutes to research it, right? Don't worry, take a quick look at it and then come up with your estimate. Plug that in. And then when you're finally done, the computer will know how long it actually took you to do it.
Mm-hmm.
And then you just start doing that. So every time you get assigned a job, you put in your initial estimate, and then the computer puts in the final number, because it knows it's been keeping track of you, checking things in and out of the repository. It's been tracking, how long you spend working on the software or the project. And then over time, it learns what's the ratio between your estimate and how long it actually takes.
Huh. That's
and he
neat.
says, don't worry about beating yourself up over underestimating the time. Just know that the software is going to adjust for that. So if you put in 2 hours, it's actually going to multiply that by 4 and come up with 8.
That's so funny.
And it says, that way I know how long it's actually going to take.
Yeah.
And you can continue to underestimate, and I'll know how long it'll actually take. and you'll
so
see
funny.
that also. So over time, if you get better with your own estimates, the system will adjust and start, bringing that threshold down to, closer to 1.0. So it's a tool to help you estimate better, and it's a tool for me, the project manager, to know how long things are actually going to take.
That's neat.
And so, I thought about, everyone does that. They're like, oh, I'll be able to whip this thing out in 15 minutes.
Yeah.
But if you just know, in my experience, I think it's going to take 15 minutes, but it actually takes 45 minutes. Then you just go, it's actually going to take 3 times as long. And it's always actually a pretty good rule of thumb that things are always going to take 3 to 4 times longer than you think.
That's what this took, 4 times longer.
It doesn't matter what it is, whether it's software development, job construction, home repair and construction.
Everything.
It's always going to take 3 to 4 times longer and consume 3 times more resources than you think.
Yep.
Yeah.
That's a good rule of thumb. I will
It's
start using that. It's just ego bruising, but oh well.
It's like the first 80% of the time is spent developing the program, and the other 80% of the time is spent debugging it.
Yes. Right?
Right.
Because you're at 160%.
Yeah.
Oh, that's so funny.
So for you, the program's going okay? How are the other people doing? Haven't started on it yet.
Mine is going.
Oh, Jack, your microphone's acting up today.
One of the things that I found kind of interesting was that in order to get the compiler to stop screaming at you, you had to malloc the information inside the external functions.
Tell me again.
So, normally when you return what the function is supposed to give in the crack.c file, there's a function in there called CrackHash, I believe.
Yeah.
And whenever I would return just a plain string, the compiler would say, "Oh, well, you're actually pointing to a location on the stack where that string is stored, rather than like an actual solid memory location." And so I was like, okay, so I got to actually allocate that memory on the stack for it to be reachable. Otherwise, it's not going to be persistent, right?
Yes, exactly. So
and then after that came all the errors of, oh wait, you haven't closed down all of the mallocs. When you're running the Valgrind, it's like, oh, memory leak here, memory leak there.
So you're talking about this function called CrackHash right here.
Yeah.
And you're going to open the dictionary file, loop the dictionary, hash each password compared to the target hash, and if they match, return the corresponding password. So that password is presumably sitting in a string that you allocated within this function. And you can't return that because that's a local variable, not a persistent one. So you do have to use malloc to allocate space for that string and then return that. But then that means, on the other hand, the caller of CrackHash then needs to free that up. So
yeah, and not to mention, every single time you hash the password inside the function itself too. So there's like, I don't know, I added like 4 different free statements.
Yeah, you got them all. Dahlgren says you got them all.
Yep, no leaks.
Good.
Did it get fixed?
Nope.
No. Did you ever figure out what was causing that? No. he's back there plugging and unplugging cables, I'm sure. So Terry, how did your program do with like the million words?
Not bad, actually. It went pretty quick.
But you could see that there was like
There was a delay.
a delay as it cracks each one, right? A second or two.
Yeah, exactly. The other ones were just instant, right? But that one, it was like 2 seconds, maybe 2.5 seconds
Between each one. And slightly varying because the word might be near the beginning or might be near the end, right? So it's kind of an uneven pace. But
yeah, and I was doing, when I did the million, because I knew it was going to take a long time, instead of doing all 20 of them, I just made a different file with just a single MD5 in it, just to run it through the million. And that way it wasn't, taking super long time.
But it took a few
So I
seconds
just did.
right, to find.
Yeah, it was a couple seconds for it to find one of them.
So what accounts for the difference in time other than just there's more? I mean, if you got the million one and you've got the 1,000 one, there's 1,000 times more words to churn through.
If I had put a break in there, I think it would have been a lot quicker.
Oh, so even
But
after you found it, you kept going?
Yeah, I just kept going.
Okay.
I didn't put a break in there.
So that would be interesting, is put that break in there and then try cracking like 20 of them and see how that does.
Yeah, let's see.
Well, trial number 3.
Hey, it's not better.
Oh yay. Yeah, so for the crack password one, it feels like I've mostly got it, but having a couple things right now. Like the first one is so when we get to return the password that we cracked, what word it was, I would assume it's just kind of like return the word or something. Let's see. Yeah, but it just tells me the address of stack memory associated with local variable word returned. That's it. Yeah, and so
that's what
that
Ben was
warning
just talking
came
about
up
a moment ago.
Oh, good. Right as I was fixing all my mic stuff.
Ben, you
Wow,
want to say briefly what you came up with?
Sorry.
Oh yeah, so when we call a function, the memory of that function isn't persistent after it exits the function, so you have to allocate the memory for that string when you return it. If that makes any sense.
Yeah, how do I do that?
No, just a malloc.
Oh, okay.
So
And
when
then
I
after you gotta free it.
run the hashes through the 1 million text, it's instant with a break in there. There's no delay at all.
Oh, okay. So let's take a look here. So I'm in your account here.
Okay.
And if I type make test, which just runs the program against the hashes that were generated, yeah, that's pretty fast. Although what it's doing here is it's running your crack program with the hashes I just generated against the Rocky 100 file, right? Because it's just using the entry that's in the make file. So if I run the program with the same hashes, but use the Rocky 1 million file, it's still fast. Why is that?
Because of the break that I just put in. Because if the break wasn't in there,
No. This is more subtle than that. So the hashes that we just cracked came from the first 100 words in the file. So they're all going to be in the first 100, right?
All right.
So we need to go into the make
Change
file.
The
and
make
actually-
file to the 1 million.
Yeah. Are you doing that or?
I can do that, yeah. All right. Much slower.
But you can see that it's a little uneven in the timing because sometimes it finds the word quickly and sometimes it has to go further into the file.
Yeah, that's neat.
So the reason for this pausing is twofold. One is, of course, there's now just more words to go through. And so when you try to crack a specific hash, it has to compare that against the hashes of potentially up to 1 million possible candidates. And it's going to find one. Eventually it finds it, and then it moves on to the next one. And then it has to compare it against the hashes of 1 million or so candidates. So it's scanning through that Rocky file over and over and over again. And reading from a file takes time. If you only had to scan through that file once, you wouldn't notice a big difference between like loading that whole file into memory all at once or reading it a line at a time. Because really the operating system behind the scenes is loading the file into memory in chunks anyway for you. But we could speed things up a little bit by loading that entire file into memory so that we don't have to read it a line at a time from the disk. If we load it entirely into memory, we spend the cost of pulling it off the disk and pulling it into memory once. And then once it's in memory, it's very quick to just scan through that file.
Okay.
Right. The disk drive is on the order of 100,000 to 1 million times slower than memory, particularly if it's a spinning disk, right? These are probably SSDs behind the scenes, so they may be not quite as slow, but there is still a significant factor in the time it takes to access a file on disk versus just in memory. So there's like probably 3 different ways that we could do this, to load this into memory. And the technique that we use and the way we build up a data structure in memory has to do a lot with what we're going to do with that. For example, are we just going to read the stuff into memory and then be able to edit each one of the lines in the file, like we're a word processor of some sort? Well, that's going to be a different way we want to load it into memory than if we just want to load it in and just access the data without being able to alter it. So, do we need to alter the the words in the file?
No.
No, we don't. Right. We're not inserting or deleting text, right? So one thing we could do, now first of all, remember a file is really just kind of like an array of bytes. It's not actually organized into distinct lines. If we take a look at the file itself, right, it's just a listing of words. So to us, it appears to be a two-dimensional entity. It's got lines, and each line has a bunch of characters on it. Let's open it up over here. But it's not really. All of these words are actually just run together inside the file. So if we picture a file as just being a long array of bytes, then we got 1, 2, 3, 4, 5, 6. And then what separates this first word from the next word?
The /n.
Yeah, there's a new line character in there. And then 1, 2, 3, 4, 5. And then a new line character. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what the file actually looks like. It's just an array of bytes with new line characters interspersed. The way it gets displayed to us every time it encounters a new line character, it just causes the cursor to go to the next line on the screen. So that's what gives it to us the appearance of being a two-dimensional thing, but really it's just a one-dimensional sequence of bytes. So we could pull that entire file right into memory. And then when we want to access each one of the words inside of the file, we've got this this file pointer, right? Is we just sort of scan forward until we find that new line character, and then we know, okay, here's one of the words. And then we can scan forward to the next new line character and know, okay, here's another word. Scan forward to the next one, here's another word. Okay, with me so far?
Mm-hmm.
Yeah?
It's similar to the picture one that we did, just with the new line rather than... Yep.
But the image was like an actual rectangular array. We actually treated that as a two-dimensional array with a fixed width and a fixed height.
Mm-hmm.
This one here...
it's a big long string.
It's a big long string, but if we picture it as being a two-dimensional thing, each one of the lines are a different length.
Mm-hmm.
So since we're accessing the file sequentially from beginning to end, we could use this technique where we kind of... Oh, and I guess by image, were you talking about the CSI one or the one where we were doing the hamburger?
CSI.
Oh, CSI, yeah, this is kind of like the CSI. It's like we're moving forward and finding the end, right, of that. And then we move forward and find the end. Oh, here the end is really well defined. There's a new line character there. The new line character doesn't appear anywhere else except at the ends of strings.
Yeah.
Right, so we can just kind of like inchworm our way through here.
Mm-hmm.
Right. So we could load this entire thing into memory and then have like a function that would just return to us the next word out of the file. We just like get next word, get next word. Kind of similar in Java where you open a file and then there's a method called next, right, that just returns the next string out of the file. So that's one thing we could do. Another thing we could do is, again, load the whole thing into memory. And then we build up another array where each element of the array points to the beginning of each word. So we load the whole file into memory, we make a pass through the file and learn where the beginning of each word is and build up this other array. Now, what's the benefit of this? Well,
Yeah, you're traversing each word rather than each byte.
so we still, to build up this array, we still have to inch our way through this file to learn where each beginning is. But we
Yeah,
only have
you
to do
only
that
have to do it
once, right? And then we learn where they are, and we store them over here.
And it'll be quicker to traverse that array than it will be the big, huge one.
Yeah, so when we now want to go and make a pass through the array again to crack another hash, we know where all the beginnings of the words are, and it's very quick to just jump through this array. Right? We don't have to inch our way through this one all over again. And the third benefit is if we wanted to jump around in the array. So if we wanted to go to this one, and then over to this one, and then over to this one, and then over to this one, we can do that very quickly because now we have an array of where all the words begin. So if I want to go and find the 100th word in the file, I just go to the 100th entry in here, and then follow that to wherever it goes. So ultimately, I think this is how we're going to build. We're going to build this. And like I said a few minutes ago, if we wanted to build a data structure where it was possible to edit each one of the words, then we would probably build something that looks like this. Again, we would have an array of pointers, like I just showed you. But then we would build something like this. So now each line in the file has its own separate string. And then we could, insert characters into this. We could delete characters out of this. But the ordering of the strings doesn't change. And we don't have to, see the problem with this one is if we want to insert a character like right here, we'd have to shove everything down.
Oh yeah.
In order to put that one character in there. Or if we want to delete a character, we would delete that character and then move everything to the left. Right, that's a huge pain. But if we have this one here and we want to delete the 4, all we got to do is slide 2 characters down to fill its spot. And if we want to insert, something like here in the middle, we just slide a few things over and we got space for it. I'm looking at my diagram going, wow, I just thought of a third way of doing it, but I don't know. Third way would be, Terry, your favorite, a linked list.
Oh yeah.
Where each line in the file points to the next line in the file. Right?
Yep.
But then again, you only get sequential access to the file. You can't just jump around very easily.
Yeah.
But at least that way, if you wanted to print out the whole file or present it on the screen, it's very easy to just traverse that linked list as you go. I think.
Would there?
Go ahead.
Sorry. Would there be an efficient way to alphabetize an array like this, so that you could binary search it later, or is that kind of a huge waste of time?
Golly, Tiffany, it's almost like you read the next assignment.
Oh, whoops.
Yeah, that's exactly what we're going to do. Right,
okay.
Right. So once we build up this data structure like this, then yes, we can sort the file. And
yeah, you would just use the string, right? For the first.
Yeah. So if we wrote our own function, wrote our own sorting function, we could leave all of the strings in the same spots here. All we do is just juggle around these pointers.
Yeah, that's neat.
Am I making sense?
Mm-hmm. Yeah, because then our array will be, even though it's pointing all weird in different directions, it will be in order of where it's going to go, right?
Yeah, let me see if I can illustrate that. So
it would be like if you had, well, I guess that's kind of a bad description, but DVDs that were all out of order, but strings that went to them for letters, and when you pulled the letter out, it pulled the DVD with it.
So initially, your array looks like this, right? So each of the words are in the order that you read them in. But then, if I rearrange these pointers, so now the pointers are going every which way. But if I look at each one of these in turn, they're pointing to these words in alphabetical order. So I can sort the words, but not by moving the words around. I can sort them by moving their pointers around. So notice that this array is still the same size as the one I had before, but the pointers are now pointing in different directions. So effectively, I've sorted it. Does that answer your question, Tiffany? She probably didn't hear me.
No,
Yeah.
Can you hear me?
I can hear you now.
Yes, it does help. Yeah, sorry, I was
Yeah.
messing with it.
So that's what we're going to do, not for this assignment, but the next one. Or maybe, I don't actually remember. I didn't look at the assignments to see whether, what happened in semesters past was I had 3 assignments for this. I had learn how to hash words, which is what you already did. Then I had hash, then I had the one that you just did or are working on currently, which is crack the hashes by reading the file in over and over again. And then the third assignment was crack them much faster by loading it into memory, sorting all the words, and pre-hashing them.
That's what you have now.
That's what we have now as the next
Yeah,
assignment?
you have. No, the next assignment is loading into the dictionary.
Yeah.
And then the third assignment is cracking passwords faster.
So I got a lot of complaints from students going, this is too much all at once, right?
Oh, I see. It was all at once?
Yeah.
Yeah.
Right, so it was
see.
hash one word and then crack the words using just the files. And which is one that Terry, you just finished.
Mm-hmm.
And then put it all together and build a big data structure and sort it and yeah. And so we ended up spending like almost 2 weeks on that assignment because it was a lot of stuff to put together. So I figured, well, if we're going to spend 2 weeks on it, I might as well just break it up into 2 assignments and kind of like incrementally get you to where we're going. So what I'm going to show you today is how to load that file into memory and build this data structure. And then what you're going to do is take that information and write a program that then cracks hashes using that dictionary that we built up. Okay, so there's kind of like two steps of this process. The first step is get all those words into memory, and then the second step of the process is build up that array that points to each one of the words. Okay? So, how do we tackle this? Yeah, good question here, right? That's what you're supposed to show us.
You would start by you would start by importing the file, and then you would make a struct that's got an array to hold that file in, and then another struct that can hold each pointer towards that array of words. Is that right?
Yeah. Okay, so we want to load words file into an array of characters, and then build an array of pointers to each word. Okay. So let's see if we can do that. I'm going to, boom, you're done. I think I'm going to need to include standard I/O. I might need to include standard library and anything else? Oh, we'll see.
String.
String? You think so?
You'll need string. Well, if you're going to compare strings, you'll need it.
Okay, so let's load these load the words file into an array of characters. So we need to open the file for reading. Let's do that. File pointer W equals fopen, and let's get the name of the file. Let's get the name of the file off of the command line. And we'll open it for reading, and then let's check to make sure it was actually opened. And now we've got our first problem to solve, which is how do we pull that entire file into memory? We know how to read it in one line at a time, and certainly we could do something like that. We could read it in one line at a time, and then every time we get a line, we can just sort of append it onto the end of this giant array that we're building up. Right, so we could read in the first word, put it into this array. Read in the second word, put it at the end of that. Kind of like we were doing with the, there was that assignment where you were building up that array of words, right?
Mm-hmm.
And either putting it at the beginning or at the end, right? Kind of like doing the same thing. We're just going to append the word onto the end, append the word onto the end, append the word onto the end.
Okay.
So in order to be able to do that, we'd have to keep track of where we currently are in the large array, and then use something like string cat to just stick it onto the end. Actually, we could probably just use string cat to do all that work for us.
Yeah.
All right. But the problem is that we're not building up one giant string. I mean, I guess we could build up one giant string, but how do we separate then each one of the words?
Well, you would just use the, oh, you couldn't use N. You couldn't use O either. I mean,
the problem is if I put the new line characters in there, then when I wanted to say, go to word number 3, it would, I get a pointer to word number 3, but then where does it end, right? There's no null character sitting at the end of that string to say, here's where that string ends.
There's also no spaces in that file.
Right.
So why don't we just add a space to separate them, and that'll be our delimiter.
What I'm trying to say is, like, if I have this picture and I say, okay, now print out string number 3, right? So we're going to follow this pointer, go over here, and then we're going to say print it out. And if we use something like printf, it doesn't know to stop at a space.
You could tell it to, though, right?
No.
Oh, okay.
It's looking for that null character.
Oh, well, you would tell it to, then you'd have to pull each one in, and that defeats the purpose, right? because you could pull it into the space. You could write a loop to pull each letter in or
Yeah.
each word in and use a space as a delimiter, but
Yeah.
that
But
kind of
again,
defeats the
that kind
purpose.
of defeats the purpose, right?
There's got to
Not
be
to store them with null characters.
Yeah, so ultimately, is to store them with the null characters in there.
But doesn't that null character end the array?
Well, if we already have pointers to the beginning location of each word, would that matter?
Well, it would kill the array. That would be the end of the array, right?
But we're using pointers to reference it, though.
But then we would have multiple different arrays. So how do you do the null character without having it, I guess, do what it's supposed to do?
Well, I don't know who was talking a moment ago. I mean, I heard Terry, but I don't know who was talking before that. But you're right. These null characters don't mark the end of the array. They just mark the end of the string.
Oh, I thought it was the end of the array.
No.
Okay.
So since we have pointers to the beginnings of each one of these words, when we ask something like printf to print out word number 0, it just starts here, marches forward till it hits the null, and then stops. And if we ask you to print out word number 2, it starts here at the P, marches forward till it hits the null, and then stops. So effectively, we've got this one giant array of characters, but embedded within it are a whole bunch of little tiny strings.
So then we would just read the file and change all of the new line characters to the to these.
Well, that's really good because you can see here's what the file originally looks like, right? With all these new line characters embedded.
Mm-hmm.
And in this version, it looks almost the same, except the new lines have been replaced by these null characters.
Mm-hmm.
So another
That would be
technique we
real
could
easy.
use is could we just pull the entire file into memory, new lines and all, and then go through it and replace those new lines with null characters?
It would be the same loop that we use to replace the new line with null characters currently. It would just wouldn't end.
It would just
Be
keep
a
going,
really
right?
small loop. Yeah, it'd be a really small loop. Well, I mean, it would do a big thing, but the coding would be tiny.
Oh, the spammer's in my YouTube here.
Mm-hmm.
Yeah, so I think we're onto something here. We can just load the entire thing into memory all at once, and then run this little loop that goes through the string, looking for the new line characters and replacing them with nulls.
We wouldn't use fgets, right?
No, because that only reads one.
Yeah.
Fget stops when it hits a new line character, and we want to just keep going.
fread.
So we could use fread. Remember when I introduced all the functions for working with files? I said fread was good for reading in bulk data.
Mm-hmm.
If you had a lot of stuff you wanted to read in and you knew how much you had to read in, fread was great for that because you just pass in the file you want to read from, where it's going to go, and how many bytes. And it just pulls that all in. The problem is we don't know how many bytes the file is.
Well, we would just calculate that real quick, right?
How could we do that?
By using that, I don't remember the command, but I know you did it. there was a command that you used to multiply the size of the array by 4 or 8.
So like some of these files are 151 bytes. Oops, some are 777. Some are 8,577,243. Right? So we don't know ahead of time how big the file is, and we can't use size of because Size
That's
of
what it
only
was.
gives us the size of the array if we've already allocated, but we don't know how big the array is supposed to be.
Well,
If I go into my program here, and I say, you know, allocate an array, character, what should I call this? Contents or something like that. Right? What number goes inside the brackets? We don't know. Right? So there's a function in C that we can call, that we can ask it, how big is the file?
fseek.
Right? So we could do something like that. We could use something like fseek to move to the end of the file, but then ask it, like, where are you? And then we can move it back to the beginning. Right? That's one way to do it. Another way to do it is there's actually an operating system call that we can do that will actually tell us how big the file is. There's an operating system call called stat. Gives us the status of the file, and it actually returns pretty much all the information that you see right here. It returns what's the permissions on the file, who owns it, how big is the file, when was it modified. So it returns information about the file. So which technique do you want to use? Do you want to use the fseek one, where we zip to the end of the file, then zip back to the beginning, and that'll tell us how big it is? Or do you want to use stat?
Well, the fseek I can figure out pretty easy, so let's use the stat. I guess the reason I want to use stat is because when I picture that being printed out, I don't know if it's going to be I don't know the right way to say it. Like, it's going to give us that information, but how do we access the information that's in it, right? Is it an integer? Is the size going to be an integer, or is it going to be...
So here's the function called stat. Well, it's not obvious at all how to call this thing, but basically it returns to you this structure. It's a struct, and inside the struct is all those little pieces of information, and the one that we want is right here.
Mm-hmm.
So what we do is we call stat, we pass in the file name that we want to get information about, and we pass in a pointer to this structure, and then it fills it in, and then we can access the size from there.
And it'll return it as an integer.
It's more or less an integer. It's actually called an off_t, which stands for offset, because files could be bigger than fit into an integer.
Oh, I see.
Right.
Yep.
So this there
That makes sense.
is probably it's a long behind the scenes. Which function is better for determining the size of a file, fseek or stat?
Probably
I don't
depend on the size of it.
Yeah, it might. Well, stat's always going to work.
Mm-hmm.
The problem with fseek is that it may actually need to do some housekeeping behind the scenes to be able to like move that file pointer all the way to the end, and then move it all the way back to the beginning. Who knows? Maybe in doing that seek, it actually like reads in the file one character at a time until it reaches the end of the file.
Yeah, maybe.
Okay, so to be able to do this, so the manual page says we need to include sysstat.h. So maybe before we even open up the file, let's do that. So we're going to go struct, stat, let's call it status. Then we'll say stat argv1 and a pointer to this status structure that we built. Now stat returns an integer. Let's scroll down to here where it says return values. On success, 0 is returned. On error, -1 is returned. And error number is set to indicate the error. Okay, so let's go int, I'll call it ret for return value. So if ret is equal to -1, if printf can't stat %s, we'll give it the reason, and then we'll exit. And this should be a negative up here. I'd be interested in compiling this program at this point and seeing what happens. Let's go clang, load words. Oh. Format is not a string. Oh, I had to put standard error on here. I always do that with fprintf. I forgot to put standard error front. There we go. So load words .c, and let's put in something like rocku100.txt. Oh, yeah, that is not going to work. There we go. All right, it didn't crash. That's good. Let's put in a file that doesn't exist, like this one. And then we get this error, can't stat, and then my gobbledygook file name, and then no such file or directory. Okay.
So then we just get, how do we pull that info out of the struct now?
So if we scroll up to the struct, we can see that inside of our structure there is an entry called st_size. Let's use the dot notation.
I like
seen
it.
that before? Seen it from Java, right?
A few times.
Yeah. Now let's go ahead and print it out. And it says size is 787. Oh, that looks pretty good.
Nice.
Is that correct? There it is. It's 787 bytes. Let's try it with...
I just did the 1 mil. And that came back super fast.
Yeah, stat doesn't even open the file.
Yeah, that's
Stat just looks
definitely a
at
better
directory
way.
entries information. Okay, so we can get the size that way. Now we can go ahead, open the file for reading, and now we can allocate our array. Okay, that seems to work. Let's try it with the 1 million file. Well, actually, I'm not even, I mean, we're not really doing anything with the array yet, so. Okay, so before we do that, before we even do the struct stat, we should, let's do this. If argc is less than 2, is that right? We'll go usage, %s, and then the file name. That way, if we run the program and we don't supply a file name, it gives us an error. Okay, so now that we've got our array, that's the correct size, let's just see if we can pull that entire file into the array. So we're going to use fread to do that. We start with the file we're reading from, which, well, actually, let me go ahead and just look up fread. I always have to look up the order of the parameters to fread. Okay, so first, boy, this is impossible to read. So, the first parameter is the array that we're reading into. The second parameter is how many elements in that array. And the third parameter is how big is each element itself. So we're reading into an array of characters. So we're going to use the number of characters in the file, and then each element is going to be 1 byte long. If we were reading in an array of integers, then we would put here the number of elements in the array, and then we would put the size of an integer so that it knew how many bytes to read in. And then finally, the fourth parameter is what file we're reading from. Okay, so first parameter is the array we're reading into. Second parameter is how long is the array. Third parameter is how big is each element of the array. And the fourth parameter is what file we're reading from. And then what it returns to us is the number of bytes it actually read in. Okay, and then, well, let's just try it out. I'm all for just seeing if that compiles and runs.
The 1 mil is too big.
Oh, what happened?
Segmentation fault.
Oh, what's going on there?
But the 100 works.
The 100 works. Any idea what's going on? Why is the 1 million too big?
Is it larger than an integer can store?
Well, it's only 8.5 million, and an integer can store up to about 2 billion.
Yeah, so not that.
I wonder if GDB tells us anything. GDB a.out core. Oh, I need to recompile the program with the G flag. So run it, let it crash, and then run GDB and see what it says here. Well, it's crashing on the F read, and that actually should have been more or less obvious that it was going to crash there because that was the only thing we added to the program since we last compiled and ran it. So I do know what the problem is, but I'm trying to explore this to see if there's a way that we can find out what the problem is if you didn't know what the problem was. I wonder if Valgrind will tell us. No? Valgrind says, everything looks great. No problems. Oh, because we didn't use it correctly. Oh, that's why it didn't work. Segmentation fault. Oh, we got a lot of stuff from it. Let's see. Client switching stacks. Invalid write of size 8 at main line 37, which is the F read. Okay. Address is on thread 1 stack. Process terminated. Access not within mapped region at address. If you believe this happened as a result of a stack overflow in your program's main thread, you can try to increase the size of the main thread stack. Can anyone kind of infer from that message what's going on?
Yeah, that it's not the allotted room to put this in isn't big enough.
Yeah, so
We need to make it bigger.
your stack in your program is kind of like of a fixed maximum size. When your C program is running, it does not really expect that you'll put giant arrays in as a local variable.
Understandable.
So we can't allocate this array as a local variable. What should we do instead? This array is not going to fit
Pointer?
on the stack. We need
Just
to put it somewhere
as
else.
a pointer. When you use a pointer, it puts it in memory, right?
So if we just said character pointer contents like this, then that doesn't actually allocate space for the array. All it does is it just says there's a pointer to the array.
We could malloc using the size.
Yeah. If we use malloc, it's going to put the array over in the heap area. And there we've got plenty of room to store stuff.
I thought that was the malloc was the same. I thought it went into the same area.
No. So
That
when
makes
you
more
allocate
sense
an
now.
array, just using the bracket notation, it goes up in the stack area, which is for local variables, and it's there's a maximum size to that. And the stack itself is a maximum size, so
Sure,
including
yeah.
all the variables you ever declare locally. When you use malloc, it goes into the heap, which is a different portion of memory, and there you've got large swaths of memory that you can use.
Cool.
So we got plenty of space here to hold this. So let's recompile it. And we'll run it. And it didn't crash. So that's good. Okay, I can see now it's 10:38 our time, and I'm going to have to actually, end on time because I have a meeting to go to right at 11 o'clock. So we'll see how far we get in the next 20 minutes, and then we got to cut it.
Yep.
Okay, so we've got it all into memory now, and now we're actually, at this point, we're done with the file. We pulled it all in, so we can go ahead and close it.
Should we free up that malloc that we did, or is that?
No, we still need it, right? We pulled it all in memory. Now we're going to walk through that array and start replacing all those new lines with these null characters. And we're going to start building up this data structure to point to where each one of those things are. But let's see if we can just go through it and replace all the new lines with null characters. Actually, why do we not do that yet? I mean, we ultimately have to do both. We have to replace the new lines with null characters, and we have to build up a data structure to point to where the beginnings of each one of these words are. Why don't we do that first?
Couldn't you do it at the same time?
We could do it at the same time. I don't want to complicate things too much, and maybe ultimately we will end up doing it at the same time. So we want to build up this array of pointers to each word. So now we need to allocate space for that array. Right? We need to allocate space for this array so that we can point to each one. Here's the problem is we don't know how big that array is supposed to be.
A reoccurring theme here.
Yeah. Because we don't know how many words are in here.
But we could
traverse
the
from
array.
The file name, right? But that's not really a great way to do it.
No, we could traverse the array real quick and count the number of new line characters, or the number of new line characters, and that would give us -1. But if we overshot it, that would be okay.
Okay, so we can count the number of new line characters, and there is a new line at the end of every single word. So we can use that to count the number of words, and now we would know how big that array is supposed to be. So we'll make one pass through the array very quickly just to count the new line characters. Okay, so let's write a quick little loop. We're going to go from 0 up to the size of the array. And let's initialize a variable here. Int, let's call it word count equals 0. And then we just quickly go if contents bracket I is equal to the new line character, then increment word count. Is that right?
Yep.
Got 1,000,000. Let's try it out of the other file here. 100. Good. So now we've got this giant array that contains all the words from the file, all the lines from the file, and we've now got a count of how many words there are in the file. Now we can build this array. Okay, so what's going to be the declaration for that? Let's say we're going to put the array on the stack, right? We're not going to use malloc yet. Let's just say we're going to put it on the stack. What would be the declaration for that array?
You would use the word count.
Okay.
It would say
so
char. Yeah.
Right.
Char, whatever your name is, word count.
Okay, so is this an array of characters?
No, but it wouldn't matter, right?
What is an array of?
Of words. Oh, it's an array of pointers.
Yeah. What kind of pointers? What
pointers
is each one
to
of these?
Another array.
What are each one of these pointers pointing to?
Oh, it's an integer.
No.
A character.
Well, they're pointing to elements of another array.
Right. So this is an array of characters.
The other one will be an array of pointers.
Right. Pointers to what? It's very important
Pointers.
to know. Tiffany's trying to say something, but her mic keeps cutting out early. So
Sorry, I'm trying to say a character.
it did it again.
Okay. Character pointers?
Yes, each one of these things is pointing to a single character. So this is an array of pointers to characters, or char pointer. Okay.
Why does that matter if we're just telling it where to go in the array? If we're just saying go to this element number in the array?
Why does it matter that these are pointers to characters?
Yeah, I mean, in my mind, it wouldn't make a difference if we're pointing to a pointer in an array or an element in an array. It's still a number, right?
It's still a number, but the compiler requires you, when you declare any type of pointer, that you tell it what kind of thing it's pointing to.
Okay.
Right? And that way you don't mix your pointers up. I don't have a pointer to a character mixed up with a pointer to an integer.
I see. Okay.
So particularly if I would dereference that pointer, I want to make sure I know what kind of thing it's pointing to, so that when I assign it to a variable, I know that that thing is going to fit into that variable.
So it's almost like a redundancy kind of thing, just to make sure that it's not. I see. Okay.
Yeah. Yeah. So ultimately, yeah, they're just numbers, they're just addresses, but for safety reason, it requires you to say what kind of thing is it pointing to. And it's not just safety, actually. There is actually a real reason, and that is when you dereference that pointer, it needs to know how far into memory do I have to go before I got the whole thing. Right? If this is a pointer to a character, I know I only have to look at 1 byte. If it's a pointer to an integer, I have to look at 4 bytes. If it's a pointer to a structure, I know I have to look at 100 bytes or whatever the size of the structure is.
Okay.
Right? That's why it needs to know what kind of thing it's pointing to, so it knows how many bytes to read in once it dereferences that pointer.
That makes sense, so that it's not overshooting that. And
Yeah.
okay, I see.
So this thing here is an array of pointers to characters, or char pointers. So if we allocated the array on the stack, we'd call it words. Word count would be the number of elements, and each element of this array is a character pointer, because each one of these is pointing to one of these characters in this other array.
Cool.
Okay, but I don't know. Is a million going to be too big?
Well, I guess we'd have to find out. I don't know how big that.
Well,
know
so
how big
each
the stack
character pointer is going to be 8 bytes, because they're 64-bit addresses. So if we allocate
already know
a
it's too
million,
big.
yeah, if we know it's going to be 8 million, right? And we tried 8 million, we know that's too big. So this is not going to work. How can we rewrite this as a malloc?
Character
You would
pointer.
just do the same. Sorry, go ahead.
Okay, sorry.
You would just say char star words equals malloc, and you're going to use word count instead.
But that would only allocate a word count number of bytes.
Oh. Well, then you would use the size of, right?
And what do I put inside that parentheses?
Char.
But whatever this thing is.
Base and all.
Mm-hmm. Okay, so if you're turning an array declaration into a malloc, this piece goes right here. This piece goes here. And this piece also goes over there. Okay, so that's how you translate one into the other. So if you know what it's supposed to look like as an array declaration, here's how you turn it into an equivalent malloc.
This is kind of off topic, but still relevant. Is what exactly is the double star mean? Like when you have like a character pointer that has the double star?
Mm-hmm.
Pointer to a pointer.
Oh, hold on a sec here. There's actually something wrong. There's actually something wrong with this. Let me back up a bit. Let me back up even more. When we call malloc, it's going to allocate this array in memory, and then it's going to return to us a pointer to where that array starts. Okay, so we're going to get back a pointer to this. Let's call it words. What type of thing is this? Well, we know it's a pointer, right?
A pointer to a pointer.
But it's pointing to what? What is this thing?
A pointer.
What specifically? What kind?
A char pointer.
It's a character pointer. So what kind of thing is words?
A pointer to a char pointer.
And how do we write that?
Double star, right?
Yep.
No?
Yep.
Okay.
So it's not true that you just copy and paste this section over here. You're going to take this part here and put it here. You're going to take this part, put it here. You're going to add on this extra star.
Could you explain exactly how the pointer to pointer works?
So all it says is it's a pointer, but the thing it points to is also a pointer.
I'm not quite grasping it.
Right, do you see the two arrows here?
Okay.
So when I had one single arrow, I said this is a pointer to a character. Right? This pointer points to a character. And I wrote that as character star.
Mm-hmm.
But this pointer is pointing to this pointer. Okay, so it's a pointer to a character pointer. So I guess one way to think about it is don't worry about like the fact that it's two arrows. Just say whatever this thing is pointing to, whatever type that is, which is character pointer, I've just got a pointer to that. And the way I make a pointer to that is just add a star onto it.
Okay. So it's just the notation.
Yeah, just add a star onto it.
Yeah, because sometimes it kind of throws me off, like the referencing, or rather dereferencing a pointer along with the way you declare a pointer.
Yeah, and ultimately we may get into that, but right now, it's just a double pointer. It's just a pointer, but the thing it points to happens to also be a pointer.
Okay.
So you just put an extra star on. All right, so let's build this. We go character star words equals malloc word count times size of character pointer. And now, here's where we would start going through that array, the really big one, looking for each new line character, replacing it with a null character, and also simultaneously storing away in this other array we stored where each one of those words begins. So we're going to loop through contents array. Store where each word begins in the words array, and then also replace new line with null character. Someone asked, do we need to cast the result of malloc to this? And in the past, you would have done that. But under today's compilers, you don't have to. It'll do the cast for you. That's because malloc actually returns a void pointer like this. And a void pointer can be turned into whatever you want it to be turned into. So void pointer doesn't really mean it returns a pointer to a void thing. It just means it returns a pointer to something. It's kind of like in Java, the object, right? Object is just this umbrella term for it's a something, right? And so this is C's way of saying it's just a pointer to something, and then you got to cast it to be what it actually is. In this case, the compiler will do the cast for you.
Can you instantiate a double pointer char like that, the char words, without putting it equal to anything? So I guess it would be, can you do char star word semicolon?
Yeah.
Okay.
And that says, I got a variable called words,
Yep.
and it stores inside of it a pointer to another pointer.
And then
words equals malloc.
Yep.
Yep.
And
So,
then you could do it all in one loop.
we'd still do the malloc outside the loop, because we're doing the malloc of that array once, and
I know.
Now we're going to loop through it and start filling in the array. Okay, but I actually do have to cut it at this point. Leave you in suspense. Cliffhanger of how do we fill in that array. Maybe you can figure that out between now and Thursday. So you're going to loop through the large array, store away in the smaller array where each word begins. So as you encounter the beginning of each word, store away at a pointer to that, and then as you encounter each new line, replace it with a null character. So there's some questions to answer there, like how do you know where a word begins?
Well, it begins after a new line.
Okay, that's pretty easy to solve, right? It's the very next character after a new line. Where does the first word begin? Where does the last word end? Right? Yeah, so the words in the middle are kind of easy, but stuff at the beginning, stuff at the end are kind of your edge cases.
It would be good to start at the end of it and go backwards.
Oh.
Because you know it's going to end at 0 if you go backwards. And then you just go wherever the new line character is minus that very first one that you find. That one you just toss. Well, I guess you would turn it into a null character, but as you go backwards and find each new line character, you would just convert it and then go +1 to that element, and that would be your pointer. I think that would be the best way.
Sounds like Terry's got some ideas here.
Doing it all in one fell swoop. I like it.
Yeah, you can't.
That's what I want to do.
Yeah. Yeah, you can do it in one fell
loop.
swoop. And what I may show you next time also is, can we eliminate this first initial pass through the array to count the number of words?
That's what I'm going to try to do.
Right?
That was my
you
goal.
can't do it with the information we have so far.
Oh,
Right?
okay.
Right?
Okay.
But what you're basically going to need is, since you don't know how many words there are, but you do need to build up this array, you're going to have to implement an expanding array, kind of like array list in Java.
I love array lists.
Yeah.
Okay.
Right. And
That's
so
my
there is a
favorite
way
array.
to do an expanding array in C.
Yeah, because that's just normal in Bash, right?
Yep. Sorry, I just blew your ears out.
Oh, you're fine.
I forgot to mute that. Okay. So that's what you work on between now and Thursday, is how can you put all those elements in the array?
Cool.
All right. Like I said, I do have to cut this short. Or
Sure.
not cut it short. This is the normal time we would end, right?
I know.
But I really have to. I have a meeting to go to. So.
All right. Cool. Well, enjoy
right.
your meeting, hopefully,
Thanks.
and we'll see you Thursday.
All right. Take
All
care,
right, bye-bye.
everyone. Bye bye.
You too.
Same for you, YouTubers. I gotta take off. But again, it could be something you could try between now and the next time we meet in 48 hours. Is see if you can finish this part of the program. Can you fill in that array with all these pointers to the individual words? And then we'll go over it on Thursday. Alrighty, like I said, I got a meeting to go to. It's starting right now, so I better pop over to that. Good to see you all. Thanks for watching. And yeah, I plan to do this pretty regularly. And you're right, C and Java do look a lot alike, but there are some giveaway syntax things in a C program to let you know it's definitely a C program and not a Java program. One is the lack of any things like class, public, private, all that stuff doesn't appear. And also the way you declare main is a little bit different. Have a good day, everyone. I'll talk to you all later. Bye-bye.